Hi everyone, welcome to the video. In this video, we are going to learn operations of single linked list. Before going to the topic, let me introduce myself. Myself, Pawan Kalyan, studying second BTech, JNTU CA. These are the topics we are going to see in this video. First topic is recap of what is linked list and types of linked list and single linked list and operations of single linked list. First of all, what is linked list? Linked list is a linear data structure that contains sequence of elements such that each element links to the next element in the sequence, and each element in a linked list is called node, such that this part is called as node. And linked lists are of three types. One is single linked list, and another one is double linked list, and the third one is circular linked list. All these are based on the type of the link part. In single linked list, in every node there will be two types, two parts. First one is link part, and another one is data part. In the link part, it stores the address of the next node, and in the data part, will store the required data or the which we want to store in the nodes. Read this. Each node has two fields. They are data field and next field. Data field is used to store actual value of the node, and next field is used to store the address of the next node in the sequence. This is the graphical representation of the single linked list. And coming to the topic, operations of single linked list. The following operations are performed on single linked list. They are insertion, deletion, display, and each one is again divided is of three types. Insertion, in a single linked list, the insertion operation can be performed in three ways. They are as follows: insertion at the beginning of the list, insertion at the end of the list, and inserting a specific location of the list. Okay guys, at first we will go through the algorithms of every operation, and at the end of every operation we will discuss about the program. The first operation we are going to deal with is insertion at beginning of the list. We can use the following steps to insert a new node at beginning of the single linked list. At first, create a new node with a given value and check whether the list is empty, such that whether the head value is equal to null. If it is empty, then set new node of link part equal to null and head equal to new node. If it is not empty, then set new node of link part equal to head and assign the head value is new node. At first, define a pointer node and an integer item, and allocate the memory to the pointer variable, and request the input from user. Assign the user given values to the data part of the pointer, and assign head value to the link part of the pointer. After that, head equal to pointer. Next topic, inserting at the end of the list. We can use the following steps to insert a new node at the end of the single linked list. Step 1. Create a new node with a given value, new node of next is as null. Check whether list is empty. If it is empty, then set head equal to new node. If it is not empty, then define a new pointer temp and initialize with head. Keep moving the temp to its next node until it reaches to the last node in the list. It means that temp of next is equal to null, and set temp of next is equal to new node. And this is the function for insertion at ending. In this function, define two node pointers. One is pointer and one is temp, and initialize integer variable and allocate the memory to the pointer variable. After that, check using if condition if the pointer is equal to null. If true, then print overflow, else assign head value to the temp, and traversal through the list using while. Assigning temp equal to temp of next. After that, if the condition fails, temp equal to null, then the loop terminates. And assign the pointer value to the link part of the temp, and null to the link part of the pointer. And next topic is inserting a specific location in the list, such that after a node, we can use the following steps to insert a new node after a node in a single linked list. First, create a new node with the given value. Check whether the list is empty, such that if the head value is equal to null. If it is not empty, then if it is empty, then set new node equal to null and head equal to new node. If it is not empty, then define a node pointer temp and initialize with head, and keep moving with the temp to next node until it reaches to the node after which we want to insert the new node, until temp of data is equal to the location. Here location is the node value after which we want to insert the new node. Every time check whether temp is reached to last node or not. If it is reached to the last node, then display given node is not found in the list, insertion not possible, and terminate the function. Otherwise, move the temp to the next node. Finally, set new node of link equal to temp of link and temp of link equal to new node. And this is the function for random insert, such that insertion at a specific location. And in this, the first line defines three integer variables: location, item, and I. And the next line defines pointer nodes. One is pointer and another one is temp. After that, the next line allocates the memory to the pointer variable. And the next two lines gets the user data input from the user. And the next line requests the user to enter the location part of the to be inserted. After that, assign head value to the temp, and we will use for loop to identify the location part using assigning temp equal to temp of link. If temp equal to null, then before terminating the loop, it will prints cannot insert and returns. After terminating the loop, we will assign temp of link part to the pointer link part and pointer to the temp of link part. Next operation of single linked list is deletion. In a single linked list, the deletion operation can be performed in three ways. They are as follows: deleting from beginning of the list, deleting from end of the list, and deleting a specific node. First of all, we will look into the deleting from beginning of the list. We can use the following steps to delete a node from beginning of the linked list. Step 1. Check whether the list is empty, such that head value is equal to null. If it is empty, then display list is empty, deletion is not possible, and terminate the function. If it is not empty, then define a node pointer temp and initialize with head. Check whether the list is having only one node, such that temp of next is equal to null. If it is true, then set head equal to null and delete temp, setting empty list conditions. If it is false, then set head equal to temp of next and delete temp. And this is the code for friend delete. And the next one is deleting from the end of the list. At first, check whether the list is empty. If it is empty, then display list is empty, deletion is not possible, and terminate the function. If it is not empty, then define two pointer variables, pointer nodes temp1 and temp2, and initialize temp1 with head. Check whether the list has only one node, such that temp1 of link is equal to null. If it is true, then set head equal to null and delete temp1 and terminate the function, setting empty list condition. If it is false, then set temp2 equal to temp1 and move temp1 to next node. Repeat the next same until it reaches to the last node in the list, such that temp1 equal to temp1 link part is equal to null. Finally, set up temp1 of link part equal to null and delete temp1. And this is the code for last delete. And next one is deleting at a specific node from the list. First, check whether the list is empty such that head part is equal to null. If it is empty, then display list is empty, deletion is not possible, and terminate the function. If it is not empty, then define two node pointers temp1 and temp2 and initialize temp1 with head. And next, keep moving temp1 until it reaches to the exact node to be deleted or to the last node. And every time set temp2 equal to temp1 before moving the temp1 to its next node. If it reaches to the last node, then display given node not found in the list, deletion is not possible, and terminate the function. If it is reached to the next exact node which we want to delete, check whether the list is having only one node or not. If list has only one node and that is node to be deleted, then set head equal to null and delete temp, such that you can delete the temp value using free. If list contains multiple nodes, then check whether temp1 is first node in the list. If temp1 is the first node, then move the head to the next node, such that head equal to head of the next, and delete temp1. If temp1 is first node, then check whether it is the last node in the list, such that temp1 of link part equal to null. If temp1 is the last node, then set temp2 of next equal to null and delete temp1 using free. If temp1 is not first node and not last node, then set temp2 equal to temp2 next part equal to temp1 of next part and delete temp1. And this is the program for random delete. And coming to the last topic of this video, displaying a single linked list. We can use the following steps to display the element of a single linked list. Check whether the list is empty using if condition if head is equal to null. And next, if it is empty, then display list is empty and terminate the function. If it is not empty, then define a node pointer temp and initialize with head. Keep displaying temp of data with an arrow until temp reaches to the last node. Finally, display temp of data with arrow pointing to null such that temp of data equal to null. And this is the function for display. In the first line of the display function, it defines a pointer node and assigns head value to the pointer. And next line, if condition checks if the pointer were equal to null. If pointer equal to null, it prints that a list is empty. Else, it prints using while loop. It prints the data part of the list using the condition pointer not equal to null. In this while loop, we will print the data part of every node and assigns pointer of link to the next pointer. By this, we have completed the concept of operations on single linked list. Hope you guys understood this concept, and I thank every one of you for watching this video.